Hi everyone, my name is David Klee, founder of Sequilibrium. Welcome to the Operations Module 14 of my course, the SQL Server on VMware Accelerator. We just wrapped up the discussion around appropriately licensing SQL Server in your virtual environments. Let's talk about another not-so-glamorous topic of SQL Server operations in virtual environments. It's time to get started talking about routine operational tasks for your SQL Server on VMware platform. Your backup strategy for both your virtual machines and your databases needs to be reviewed and validated often enough. We'll talk about new virtual machine deployment and ways you can streamline this process, as well as some fun ways you can perform pre-production database refreshes as a whole a lot faster than you do now. We'll then end the module in a deep dive on capacity planning for your SQL Server on VMware farm. First up are our routine operational tasks. You know as well as I do that we all tend to work in isolation. DBAs tend to do their own thing to get the job done, and usually we work in a little bubble where we usually don't really know exactly what the other IT divisions are doing. This becomes a real problem when you're working on truly shared everything environments such as these. One little change in another layer that is very innocent in its intention could absolutely derail your performance and availability at your database layer. We have to find better ways for all parties that manage these platforms to work together. Software development has a lot of different development methodologies such as DevOps that are used to help streamline the process and basically require that the components of software development work more closely together. It's come a long way in the last decade. There's a newer methodology called DataOps that is hoping to do similar results at the database level development. DataOps essentially brings aggressive telemetry and feedback loops into each phase of the database development and operations lifecycle. In essence, it provides checks and balances with feedback at every step whenever anything in the environment changes. I highly encourage you to read up on this new methodology and see if your organization is willing to adapt its practices and processes. Embracing positive change of managing your data, as well as the knowledge in this course of how each component works together, is vital to helping to modernize and streamline your data platform. This knowledge helps every member of the data platform understand the perspectives and points of view from the other members of the team. Streamlining these tasks sets a foundation for having everyone work much more closely together and working better together for new projects and reactive day-to-day operations. As I mentioned in the host cluster module, one of the very first things you should request is read-only access into either VMware vCenter or vRealize Operations Manager so that you can get access to the performance statistics underneath your critical servers. As I also mentioned in that module, if they've not yet changed the statistics collection level or are not collecting this information with VROps, they really need to do so. Having this information means that you have much more vital information at your fingertips available for a lot longer period of time to be able to do postmortems in the event of performance challenges. I've talked before about the need to stagger the runtimes of very compute resource intensive routine operations. It is really important to have a solid map and stagger these the best that you can. As the environment continues to scale, you'll find new points of inflection in the environment, especially in these shared environments. Maintaining the operational efficiency of this platform is one of the primary goals to ensuring that we have consistent performance across the board. One function that I didn't spend too much time earlier is called a virtual machine snapshot. The snapshot gives you the ability to revert the virtual machine backwards to a point in time. It's quite useful for being able to roll a machine back very quickly if things happen like botched Windows updates or failed application upgrades. It can include the contents of memory in case you want to save that if you decide to ever recover the virtual machine. If you decide to leverage these, make sure to name the snapshot appropriately so that you can, at a glance, know what the snapshot was for and when it was taken. Make sure to leave an appropriate description as well. This is not just for you, but for anybody else in the environment. If I see a snapshot with a clear description that says, "Do not delete until a certain point in time," I'll probably leave it alone as needed. If I just see a snapshot labeled snapshot, I'm gonna immediately be sending out emails to try to figure out what this is for and why I can't remove it. These are not to be used as backup points. These are simply for point-in-time operations that should be removed as soon as humanly possible after your operation is done. Whenever a snapshot is present, your virtual machine disks have delta disks associated with them. Believe it or not, CPU scheduling pressure can occur as these delta disks grow. You can see this for yourself as the virtual machine co-stop counter will start to become more active the longer these virtual delta disks are present. There is a little trick where if you want to be able to revert back an operating system from a failed OS level patch but want to retain all the changes on your SQL Server data and log disks, you can mark those disks as snapshot independent. What this means is that the snapshot does not track any changes on that particular virtual disk. If you have to revert the virtual machine backwards, it'll revert back on the other dependent disks, but not this one. That's really handy in case you have transactions coming into a database that you don't want to lose if you have to revert an operating system back to a previous state. I talked in the previous modules about using vMotion to relocate a virtual machine from one physical machine to another. If you find the routine vMotions cause application-level disconnects, you should consult with the application owner to see if there are any changes to the application or its connection mechanism to better insulate when a vMotion operation occurs. Your applications need to be resilient enough to treat this as a TCP retry operation so that the application is not disrupted when this occurs, because it needs to happen. In addition to relocating a virtual machine from one host to another, VMware gives you the ability to relocate a virtual disk from one data store to another while it's in use. It's called a storage vMotion. It'll start copying the contents of the virtual disk from one data store to another transparently while you use it. As soon as the copy is completed and both are in sync, it flips the virtual disk pointer to the destination disk and then deletes the source. These operations are incredibly useful for consolidated SQL Server management. If your storage array is not one of the faster models on the market though, these operations can slow down the SQL Server disk operations and can potentially clog the network or interconnects to the storage. I'm a huge fan of storage vMotions underneath SQL servers when needed, but generally not during business hours. If your storage arrays comply with a VMware standard called the vStorage API for Array Integration, or VAAI, you might be able to speed up this operation. Since the arrays understand where the data is actually at, we can push this operation onto the SAN and not have to worry about it traversing the interconnects to the host and back. Normally during a storage vMotion, the block is read from the SAN, copied through the host to the other data store. Why send the data over the interconnect if the destination is on the same SAN as a source? This API is how VMware instructs the SAN to perform the operation on the backplane of the unit and simply report its progress and when it's completed. I feel a lot more comfortable doing these operations during the day if your SAN is VIA aware. Another really cool trick is when you go to migrate from one storage device to another. If these are physical servers with physical SAN LUNs, we'd essentially have to perform a SQL Server database migration to get all these files from an old SAN to a new one. With a storage vMotion operation, we can relocate these virtual disks from the old SAN to the new SAN the same as if we moved them from one data store to another. If your storage and interconnects are fast enough, we can do this while they're running and potentially during the day. Even if they're not that fast, we can still do it while it's running. I'd probably just do it after normal business hours. Let's switch gears to ways you can use your backup and recovery strategy to improve your business continuity plan. Like I've mentioned before, there are 3 layers to recover the system that we need to be aware of and understand the perspectives of the people who manage each layer. The layer that your virtual machine admins are most nervous about is the virtual machine level restores. If you've never validated that they can recover the virtual machine so that you can start a database restore, you really should do that as part of your next recovery test. Not only do we want to make sure that the virtual machine is able to be recovered so that we have a platform to restore the databases back into, but we need to understand approximately how long that process takes. I have a number of war stories where the backup to disk destination for the virtual machine backups was an appliance that featured extreme compression and deduplication ratios. The amount of time to back up the virtual machines were fairly reasonable, but the time taken to recover a virtual machine in the event of a disaster was an order of magnitude higher than they expected. The last thing you want to do is find this out during an actual emergency. The next layer is making sure that the operating system itself is intact. This may happen through you as a DBA being able to get to the SQL Server. It might also be a different team that validates to make sure that the OS is communicating with Active Directory properly. You need to make sure that you have quick means to recover both the databases and the most recent transaction logs in the event that an issue occurs. This entire process needs to be mapped out end to end so that the C-level is aware not only of the process taken to recover a system, but the time expected until the server is back up and running. One trick that I love to employ is to leverage a non-routable virtual machine network to perform my restore testing into. Think of it this way. We talked about virtual machine networking and dedicated virtual machine networks for a certain purpose. Your virtual machine administrators can simply remove the routing from that virtual machine network so that the virtual machines inside that network can communicate properly, but traffic cannot escape or enter that network. If you look at the diagram on the screen, you'll see that we have a normal virtual machine host cluster. We have our server production network. All servers in this network can communicate with the other servers as appropriate in and out of this network. Have them create that isolated virtual machine networks. It's usually a non-routable VLAN. Have your virtual machine administrators restore a test copy of last night's virtual machine level backup into this network. Clone an Active Directory domain controller into this isolated network. At this point, this is not a production-like environment. This is your production environment and is able to be powered on with no machine name or IP address changes. The presence of the domain controller means that you can test services that rely on Active Directory service accounts to turn on. It means that we can now test the entire SQL Server environment as it was backed up and restored in an isolated manner. When we're happy that the restore achieved our goals, simply turn it off and destroy that copy of the virtual machine. The best part about this is that you should be able to automate this process. Integration with your virtual machine layer backup software and a little elbow grease with PowerShell should allow you to perform functional validation testings in an automated manner. If you can automate this process, then you'll actually have the ability to restore the virtual machine in an emergency and be able to tell your C-level exactly when the databases were restored and how long it's going to take to recover them. You can tell them that your business will be back up and running in 47 minutes end to end, so go get a cup of coffee and chill. That level of confidence in your recovery strategy is almost unheard of in the enterprise, but is desperately needed. If you can use these tricks to streamline your business continuity for your databases, you'll be an absolute hero when you save the day if there's ever a major issue. Now let's talk about some tricks that I love regarding quick deployment in new SQL servers. If you need a new SQL server, your virtual machine administrator should not be deploying a new virtual machine and reinstalling and patching an operating system every single time. That process would take hours or days and would be an absolute nightmare to manually do each time. What they should be doing is deploying a new virtual machine template. They can pre-construct a new virtual machine that is fully patched and has installed everything they normally need to manage your servers. When needed, this virtual machine can be cloned and a new virtual machine deployed from it. Sysprep can be used to customize the guest operating system as soon as the deployment is completed. VMware actually has an interesting ability to define what is called a customization specification. It gives you the ability to predefine certain things, such as the Windows activation key, certain networking settings, and adding the machine directly to a domain. It means that if I want to deploy a new SQL Server for you, all I would need to do is define a customization specification with the machine name, the IP address, set of virtual network specifications, and the customization will do the rest, and I have my new virtual machine ready to use in between 5 and 10 minutes. Many people ask me if they should pre-install SQL Server into this virtual machine template. I generally say no because there's a handful of things inside SQL Server that do not sysprep well and reset the machine name. I find that SQL Server reporting services and a couple of pointers inside SQL Server integration services are prime examples of this. However, at this point, you should have scripts that you can use to do silent installations in new SQL servers and whatever other software you normally need. Part of the customization specification can be to execute a script at the end of the customization. I want to help you streamline your new SQL Server installation in a manner that you can plug into your virtual machine deployment specification process. The automation of SQL Server installations is rather easy nowadays. Automation at your instance level setup is pretty straightforward with a couple of few basic commands. Since you can run PowerShell as part of the VM customization specification, I would highly suggest that you check out the DBA Tools PowerShell module for database administrators. You can find it available at dbatools.io. They have a commandlet called install DBA instance. If you install DBA Tools as part of your deployment specification run once script, you can then point this commandlet to your SQL Server installation media and perform silent installs that occur automatically after your virtual machine deploys. Another little trick that I love to mention is to use the exact same restoration trick and tip to clone your SQL servers into new virtual machines in this offline network so that you can test destructive updates. It could be as mundane as validating a new cumulative update is not going to cause any unexpected issues. It could be as massive as executing a massive change script associated with an application upgrade. Clone the production servers into this isolated network, clone an Active Directory controller into it as well, fire up the SQL Server to perform whatever testing you need. As soon as you're done, tear it down. If you encounter any snags during your testing, you would have hit this in your production environment, and now you can re-clone and retest to work through the process of fixing the issue before you hit it. Once you upgrade this process, you know exactly what you're going to hit during your production upgrade. Take a snapshot, perform the upgrade, remove the snapshot as soon as you're done. Now let's talk about some tricks that I have related to production to pre-production database refreshes. How many of you perform periodic refreshes of production databases onto pre-production systems to help development do some testing before your changes go live? If the databases are really small, this process is no big deal. If you have to back up, copy, and restore a really large database onto a pre-production environment, this process can take hours or days. What if there's a better way? There's actually several. The first method is with cloning the virtual disks underneath your production objects and copying them into a location to attach to the pre-production server. A little bit of PowerShell can automate this for you. You take a snapshot of the production virtual machine, drop the virtual disks on the pre-production server underneath those databases, copy the virtual disks from the production virtual machine to a location that the pre-production machine can communicate with. Attach those copies of the virtual disks to the pre-production server. Rescan your storage inside Windows, bring the volumes online, and now your databases are ready to attach to the pre-production SQL Server instance. The faster your platform, the faster this operation can complete, especially if your storage array is VIA compliant. If you want to leverage a storage level feature to make this even faster, check with your storage array vendor to see if you have support for something called a writable SAN/LUN snapshot. If your array supports this operation, you're in luck. A little bit of PowerShell will go a long way here. Take a SAN/LUN that your production database is on. This LUN is mapped to a VMware data store where your virtual disks are at. Create a snapshot of the LUN on the SAN. This is a metadata operation on the SAN that should take only a few milliseconds to complete. Appropriately zone and present this LUN back to VMware as a new LUN. Rescan the storage inside VMware to see the new LUN. Add it as a new data store. You might need to resignature the LUN inside VMware to make this work, but it's pretty straightforward. Now attach the virtual disks to the pre-production virtual machine. Verify that the storage is online inside the virtual machine and reattach the databases. Once this process is completed, the act of refreshing those databases is as straightforward as this. Take the pre-production database offline, go to the SAN and refresh the SAN/LUN writable snapshot. Rescan the VMware's data stores, reattach a database. I've successfully done this on a production server with a 71 terabyte database to refresh it from production to a pre-production server. When they were doing a backup and restore, the process took 14 hours, and that's pretty darn good. In using the SAN/LUN writable snapshot process, the entire process took 38 seconds. This process is now quick enough that if they need to do a refresh, they can issue it as needed, and before they're done getting a cup of coffee, the refresh is complete. That shows us some of the true power of leveraging the raw power of the hardware to do our dirty work. In some cases, it's certainly more efficient to do it this way than to use some of the more traditional methods. Now let's talk a little bit about capacity management. Not really one of those glamorous topics, but it's absolutely essential to maintain performance and minimize your capital expenses in these environments. First of all, capacity management is incredibly hard. Most organizations that I see fail at this miserably. I say nicely because they don't know any better. Step number one is to make sure that every single thing that we do in this environment does not put us into an unsupported state. These environments are shared and constantly changing. The performance characteristics can change on the fly as workloads spin up and spin down, and the business can change at the drop of a hat. This is one of the biggest challenges that I see in the largest balancing act to make sure that we maintain performance and squeeze the most out of our SQL Server licensing for these environments. We need these environments to be as inexpensive to operate as they can while maintaining absolute flexibility so that the environment can run as fast as the business and not the other way around. I spent a lot of time in this course talking about right-sizing the virtual machines. That covers a micro-level point of view on that individual virtual machine while maintaining its performance and availability. We now need to zoom out a little bit, especially if you're dealing with environments of the moderate to high scale. I despise environments that are strictly built of one-off custom deployments. We need to make sure that we have some sizing standards in our environment that'll help us right-size individually but maintain continuity and standardization. The goal is to maintain the best possible relationship between virtual machine host density and maintaining performance. We can leverage all of our CPU and other resource scheduling characteristics and performance metrics to make sure that we get the best of everything. One of the patterns that I talked about before is called t-shirt sizing. Your traditional t-shirt sizes are small, medium, large, extra large, and beyond. When I employ this in modern data centers, this gives me the ability to specify a blanket configuration for a given scale. A small virtual machine, for example, is 2 CPUs and 16 gigabytes of RAM. The virtual disk configuration all starts with a predefined number of virtual disks and drive letters. A medium deployment has the same disk configuration, but with 4 CPUs and 32 gigs of RAM. The large is 8 and 64, extra large is 16 and 128, and so on. We'll always have our custom deployments to accommodate the statistical anomaly. Anything that you classify as a custom machine should have exceptions well documented as to why the machine does not fall under the normalized standards. We're always going to have these, but we should know why they don't conform to any of the normal sizing practices. Now let's take a look around the host. If we're doing enterprise-level host-based core licensing, we should be able to understand approximately how many slots exist per physical machine that we should be able to place normal virtual machine workloads on. I stress normal here because we don't know exactly what the individual virtual machines are doing. This is where understanding your virtual machine CPU scheduling at a micro and macro level and understanding at what number of slots per machine with a normal workload can you accommodate while maintaining performance. In this example, we have a 2-socket 18-core Xeon Gold CPU with 768 gigs of RAM. If we're engineering this host cluster to accommodate one host being removed from the cluster, do the math on how much RAM you need in reserve no matter what per host. Based on this footprint of available resources, what can we do with the available compute resources? Let's dive into this further. The host has 36 physical CPU cores. If we assume that an N-1 memory architecture means 20% of the host memory needed to be reserved, that gives us 614 gigs of available memory to allocate to the SQL Server virtual machines. If you take a look at the assigned compute resources for the different scales and start to extrapolate out the number that you'll feel will successfully operate with minimal CPU overcommit to maintain performance and watching the memory footprint climb, how many virtual machines of each scale would you be able to successfully deploy on a single host? In this example, we'd fit 8 small, 4 medium, 2 large, and 1 extra large onto the host and still have 102 gigs of host memory available. Our CPU overcommit ratio would be 1.78 to 1. Keep in mind that this is a paper consolidation exercise. This in no way takes into consideration what your virtual machine CPUs are actually doing with their workloads. If they're relatively normal and somewhat quiet CPU consumers, this example works great. You can monitor CPU ready and co-stop times to understand the net performance impact on each virtual machine. These consolidation ratios are certainly not out of the question. We have many consolidated environments where we're quite comfortable doing 2.5 to 1 CPU overcommit because their virtual machine CPUs themselves are lightly used. What are your CPUs doing, and how much density can you get while maintaining performance? Let's take a deeper look with the spreadsheet that I'll share on this module. Many organizations want the ability to charge back the associated cost of the virtual machine to a given business unit. Let's run through a quick example of how I do that. If you take a look at our t-shirt sized virtual machines with their CPU and memory allocations and a rough approximation of the number that we can fit on a single host, that gives us 64 total CPUs and 512 gigs of memory associated. In the other example, if we have 36 physical CPU cores with 768 gigs of RAM and each host has 20% of its host memory reserved for memory tolerance, that gives us our basic calculation of virtual machine overcommit ratios and host memory available. Let's take a look at our pricing on this particular host. Using Microsoft's list price for SQL Server Enterprise CPU core licensing direct from their website, it's over $13,000 USD for a 2-core license pack. For physical CPUs on this machine, we'll need 18 of these 2-core packs. That brings us to $247,000 USD estimated licensing cost. Now, I'm estimating a license discount of 25%. Your prices could be completely different with this example. That brings us to just under $186,000 USD for the estimated price to license this host for Enterprise SQL Server. Now add 25% for software assurance so that we have the virtual machine mobility rights to move them to other hosts. That brings up the estimated price to $232,000 USD. The estimated price of that physical hardware host for a normal 2U rack mount server is approximately $30,000 USD. Add the cost of the hypervisor of VMware vCenter. Add Windows Server Data Center licensing for your operating system. That puts us at an estimated price for one physical machine at $287,000 USD. Based on the virtual machine scale, we can estimate that a host compute slot becomes 1 CPU and 8 gigs of RAM. A virtual machine is 2 slots, a medium is 4, etc. Divide the number of slots available on the host, in this case 64, by the total slots consumed, and you can understand the price of a given slot on a 5-year life cycle. You're now able to charge back the price of a given compute slot to a given business unit. Keep in mind that this does not accommodate the price of any management tooling, power, cooling, enterprise storage, or any of the other associated costs with that server. Hopefully, this will help you get started with your capacity management and chargeback of what it actually takes to run one of these in your data center. Just for giggles, add storage cost into this architecture and then compare this with the cost of the public cloud. You might find the cost of the cloud is not much higher than what you've already expected. That will take care of the operations module. We spent a lot of time talking about operational tasks, tricks that you'll use for backup recovery validation, streamlining of new virtual machines and SQL Server deployments, as well as ways to speed up your pre-production refreshes. We wrapped it up around the discussion on capacity planning and management. I'll see you in the final module as we wrap up this course.